Good morning, everyone. Welcome back to next lecture. Today we will continue our discussion on input-output analysis. See, in the last lectures, we discussed what actually the input-output analysis means. We discussed its various assumptions, input-output table, technical or input coefficient, and general formula for finding the output of each industry. See, input-output analysis is an economic method used to study the interrelationship and interdependence between different sectors of the economy. We have derived the formula by comprising the technical coefficient matrix, output matrix, and final demand vector. And also we solved the problems related to the two industry or two sector models. Today, we will discuss the problems related to the three industry or three sector models. Consider one example. We have given the input output table, and here from the given input output table we have three industries are there: coal industry, iron industry, and steel industry. And we have also given the final demand and also the total output. So here also it is representing coal, iron and steel, and the labor days which is required, which is also mentioned here, and then the gross total output is also given here. And what we want to do, from the given input output table, we want to find out the coefficient matrix. Then we also want to check what actually the Hawking-Simon conditions, whether it is satisfied or not. Then find the output of the various industries. Then we will go for, see here, what happen if the final demand is changed by 10, 10, 10 respectively by coal industry, iron industry and steel industry. So that what is the new output. Then we also want to find out what actually the intermediate demand is. So from the given input output table, first we are going to find out the coefficient matrix. See, from the given table, see each element, that is here it is each number, that is 2 in the second column, 2, 5, 3. These are the three industries: coal, iron and steel. So these each values or each numbers we are going to divide with 16. First column we are going to divide with 16. So it will be 2 by 16, 5 by 16, 3 by 16. Similarly, the second column, that is 4, 7 and 2. These numbers will be divided with the 24. See here, it is 4 divided by 24, 7 divided by 24, 2 divided by 24. And the third column we are dividing with the third number here, that is 20. So here it will be 3 divided by 20, 5 divided by 20 and 4 divided by 20. So we have a 3 by 3 matrix. We are going to simplify this particular matrix, and this matrix is, we are denoting in terms of A, matrix A, and this is nothing but it is a technical coefficient. See, we are going to simplify it by dividing each numbers. See here, 2 by 16 which is equal to 0.125, 4 by 24 which is equal to 0.166, 3 by 20 which is equal to 0.15, and accordingly the each numbers can be divided here, and accordingly we will get the 3 by 3 matrix like this. So here the matrix A, which is equal to 0.125, 0.166, 0.15, 0.312, 0.291, 0.25, 0.187, 0.083 and 0.20. So here, see, this is the, what we can say that it is the technical coefficient. So after finding the technical coefficient, see, we are also writing here the demand vector, that is B, final demand vector, that is 7, 7 and 11. So this is, we are denoting in terms of B, or it is sometime it is used as a D also. So it is 7, 7, 1, we can say that it is final demand vector. Now after finding the technical coefficient, that is given matrix A, we are going to find out 1 minus A, because finally we want to find out the output of the each industry here. See, identity matrix minus the given matrix A, that is coefficient matrix. We know we are going to introduce here the identity matrix with the size of 3 by 3 because we have matrix A having the 3 by 3 order. So we are introducing a 3 by 3 identity matrix and then subtracting the technical coefficient matrix here. So if you go for subtracting these two matrices, of course you will get 1 minus 0.125 which is equal to 0.875, 0 minus 0.166 which is equal to minus 0.166, then 0 minus 0.15 which is equal to minus 0.15, then here in the second row 0 minus 0.312 which is equal to minus 0.312, then 1 minus 0.291 which is equal to 0.708, and accordingly we can also subtract the remaining elements. So this is identity matrix minus the coefficient matrix. See here all the diagonal elements are positive, 0.875, 0.708 and 0.80. See, all these diagonal elements are positive. This is the one of the condition which should satisfy, especially in order to find the inverse, so that we can go for finding the output of the each industry. So first condition of Hawking-Simon is actually satisfied. So we can say that main diagonal elements all are positive. So after finding this identity matrix minus the coefficient matrix, we are going to find out the determinant value of given matrix. So the determinant value here, we are going to take the first element 0.875, crossing the first column and the first row. Then we are going to multiply, see here, the 0.875 into 0.708 into 0.80, which is equal to 0.556 minus, then minus 0.125 into minus 0.083 which is equal to minus 0.020. Then minus second item, this is minus, so minus will become plus here. So 0.166 into crossing the second column and the first row, then we can multiply minus 0.312 into 0.80 which is equal to minus 0.25 minus 0.25 into minus 0.187 which is equal to minus 0.046 minus third element, that is here it is minus already there, so that we are putting here the minus 0.15 into crossing the first row and the third column, it is minus 312 into minus 0.083 which is equal to 0.025, then minus see plus 0.708 into minus 187 which is equal to plus, minus will become plus, so it will be 0.132. So if you go for simplifying it, then here 0.556 minus 0.002 which is equal to 0.546 multiplied with 0.875 plus 0.166 into, then if you go for taking the difference here, you are going to add because minus here. So here 0.25 minus 0.046 which is equal to minus 0.296 minus 0.15 into 0.025 plus 0.132 which is equal to 0.17157. So now if you go for multiplying it, then you will get 0.477 minus 0.049 minus 0.023 which is equal to, see, determinant value 0.41. So here the determinant value is equal to 0.41. Now we are going to calculate the inverse of this given matrix. So in order to find the inverse of given matrix, first we have to calculate the minor, then cofactor matrix, then adjoint, then ultimately we can go for finding the inverse of matrix. So first we are going to find the inverse. Before that, see, the Hawking-Simon conditions are satisfied. This was also our second question. The Hawking-Simon conditions are satisfied or not. See, here all the diagonal elements are positive. So this is the one of the first condition for Hawking-Simon condition, that is all the diagonal elements are positive. Then the determinant value, the second condition was determinant value is not equal to 0, or it should be positive, 0.41. So the matrix have all the diagonal elements are positive and the determinant value is also positive, we can say that the Hawking-Simon conditions are satisfied. Now we are going to find the minors and cofactors. See, we have the given matrix here. We are going to find the minor of the first element. Then by crossing the first row and column, see, it will become, I am already calculated here by multiplying 0.708 into 0.80, then minus 0.25 into minus 0.083, then you will get 0.546. Then after getting the minor, we can also calculate the cofactor of that concerned minor, which is equal to minus 1 raised to the power 1 plus 1, which is equal to minus 1 square into 0.546, which is equal to 0.546. Then we have the second minor also, which is calculated here, minus 0.296. Then it is minus 1 cube, which is equal to minus 1 into minus 0.296, which is equal to plus 0.296. The third minor is equal to 0.157, and we are going to calculate the cofactor as well. So it is 1 into 0.157, which is equal to 0.157, and M21 here it is minor is equal to minus 0.145, and we have minus 1 cube, so it is minus 1 into minus 145, which is equal to 0.145. Similarly, we can also calculate the remaining cofactors. So accordingly, we have the 9 minors and 9 cofactors are there. So all the cofactors are found here. I am writing here separately all the cofactors: C11, C12, C13, C21, C22, C23, C31, C32, C33. So we have the 9 cofactors as well. See here, I am going to write each cofactor separately: C11, C12, C13, C21, C22, C23, C31, C32, C33. We have 9 cofactors are there. So after writing each and every cofactors, see, we can go for finding the cofactor matrix. How can we write the cofactor matrix? If we are going to replace the original elements in the original matrix A, then we can say that we will find the cofactor matrix. See, we are going to replace here, and ultimately we will get the cofactor matrix C is equal to, we are writing here 0.546, 0.294, 0.157, then 0.145, 0.670, 0.103, 0.147, 0.264, and 0.568. See, after finding the cofactors, see, we are going to find the adjoint of a given matrix. See, how can we find the adjoint? If you go for interchanging rows into the columns, that means if you find the transpose of cofactor matrix, then we will get the adjoint. So the first row will become the first column here, the second row will become the second column here, and the third row will become the third column here. See, after finding the adjoint, we can go for calculating the inverse. 1 minus a, that is all raised to the power minus 1, that is inverse of given matrix, and then we are going to multiply with the vector, that is final demand vector. See, here we are. So after finding the adjoint of a given matrix, we are going to find the inverse, and then which is multiplied with the final demand vector D. So here after finding the adjoint of a given matrix, we are going to find the inverse of given matrix, then which is multiplied with the final demand vector, that is D, so that we can find the total output. So here the determinant value, that is 1 by the determinant value is equal to 0.41, which we are already calculated, into this is the adjoint matrix. This is the adjoint matrix which we are already calculated in the previous slide. Into, then see here, it is the final demand vectors. Final demand vector here it is 7, 7, 11. Now if you go for simplifying it, see, first we are going to multiply the first row with this particular column. Of course, we are going to multiply it. We have a 3 by 3 matrix and we have a 3 by 1 matrix. Of course, the matrix multiplication is possible. And if you go for multiplying these two matrices, then we will get a 3 by 1 matrix. So first row we are going to multiply with these column numbers. So here 0.546 into 7 plus 0.145 into 7 plus 0.147 into 11 divided by C 0.41. So it will give the output 1, which is equal to, if you go for simplifying it, then it is 0.546 into 7, which is equal to 3.822. Then 0.145 into 7, which is equal to 1.015, plus 0.147 into 11, which is equal to 1.617. Divided by 0.41, if you go for simplifying it, then you will get 15.74. We can say that around it is 60. It is 60. So here, after finding the first output, again we are going to find the second output, that is x2, which is equal to 0. The second row we are going to multiply with this particular column. So it will be 0.294 into 7, 0.670 into 7, plus 0.264 into 11 divided by 0.41. So it will equal to 2.058 plus 4.690 plus 2.86 divided by 0.41, which is equal to 23.43. We can say that it is around 24. Now, similarly the third output, see here we are going to consider the third row and multiply with this particular final demand vector. So it will be 157 into 7, 0.103 into 7 plus 0.568 into 11 divided by 0.41, which is equal to 1.099 plus 0.721 plus 6.248 divided by 0.41, which is equal to 19.67, which is equal to around 20. So we have the output x1, x2, x3, that is 16, 24 and 20. I am making it round. Okay. See here, the given question that if the final demand vector is going to change by 10, 10, 10, that means with the existing demand, there is an addition of 10 and 10, 10 in the each and every industries, then what is the new output? See, in this case, we are again going to use the same formula, that is finding the inverse, then multiplied with the D. See here the final demand we are going to substitute this 10, 10 and 10. So here of course it is 1 by the determinant value, that is 0.41 into the adjoint matrix here, then multiplied by 10, 10, 10. Then it is equal to, see we are going to multiply the first row with the final demand vector. So it is 0.546 into 10, 0.145 into 10 plus 0.147 into 10 divided by 0.41, which is equal to 5.46, 1.45, 1.47 divided by 0.41, which is equal to 20.44. Similarly, we have the second output. See, we are going to consider the second row and multiply with the final demand vector. So it will be 0.294 into 10, 0.670 into 10, 0.264 into 10. So divided by 0.41, which is equal to 2.94, 6.70 and 2.46 divided by 0.41, which is equal to 29.95. Similarly, the third output, that is we are going to consider the third row and multiplied with the final demand vector. So it is 0.157 into 10 plus 0.103 into 10 plus 0.568 into 10 divided by 0.41, which is equal to 1.57, 1.031 plus 5.68 divided by 0.41, which is equal to 20.19. So if the final demand is changed by 10, 10, 10, then the changed output is this one. Already we have the given output. So we are going to add, the old output was x1 is equal to 16, x2 is equal to 24 and x3 is equal to 20. And the changed output, which we are already calculated here, 20.44, 29.95 and the 20.19. We are going to add these two so that we will get the new level of output. So here the x1 new output is equal to 16 plus 20.44, which is equal to 36.66. Similarly, x2 is equal to 24 plus 29.95, which is equal to 53.95. And the third output, that is x3 is equal to 20 plus 20.19, which is equal to 40.19. So this is the new output after changing the final demand vector by each industry, the 10, 10, 10. Then this will be the changed output level. See here, we also want to find out the intermediate demand or inter-industry demand. So here the given general formula, that is x is equal to ax plus d. And if I am subtracting ax from the both side of the equation, then it will become x minus ax is equal to d. Now here I am going to take d into the left side and ax into the right side, so that the equation will be rearranged as x minus d is equal to ax. See what actually this is showing here. X minus d, that means output minus the final demand, which will give you the inter-industry demand. This ax is showing that it is in inter-industry demand, or we can say that intermediate demand. So in both way you can find, either you can multiply the coefficient matrix with the output, or you can subtract the final demand vector from the total output. So that also you can find the intermediate demand. So here x is equal to, we are already calculated earlier, that is 16, 24, 20 minus the final demand vector which is given in the question, that is 7, 7, 11. If you go for subtracting the final demand vector from the output, then see 16 minus 7 which is equal to 9, 24 minus 7 which is equal to 17, 20 minus 11 which is equal to 9. So this will be your intermediate demand. In other ways, you can also find out the intermediate demand. See, we have a given the coefficient matrix, and if you go for multiplying the coefficient matrix with the output, that is equal to 16, 24, 20. So here, if you go for multiplying these two, then it will produce 9, 17 and 9. So both are equal here, 9, 17, 9, 9, 17, 9. So in this way, we can find the intermediate demand. So now we are going to consider another example. See, we want to determine the total demand of X for the industries 1, 2, 3 from the given matrix of the technical coefficient A and the final demand vector D. See here, the coefficient is given. In the earlier example, the coefficient was not given, but here the coefficient is given and the final demand vector is also given. And we want to find out what actually the total demand X for the industries 1, 2, 3. That means we want to find out the output of each industry. So here, first we want to find out the identity matrix minus the coefficient matrix. So here identity matrix with the same size, that is 3 by 3, that is given here. Then minus A. So if you go for subtracting the coefficient matrix from the identity matrix, you will get identity matrix minus the coefficient matrix, which is equal to 0.7 minus 0.4 minus 0.1 minus 0.5, 0.8 minus 0.6 minus 0.1 minus 0.3 and 0.9. After finding the identity matrix minus the coefficient matrix, then we want to find out the determinant value. We are already know how to find the determinant value. I am not going to discuss here again. If you go for solving this particular equation, then you will get the determinant value is equal to 0.151. All the processes are given here, and ultimately the determinant value will be come out with 0.151. After finding the determinant value, the next step is to find the minors of the given matrix. So the minors are given here. We have 9 elements here because we have a 3 by 3 matrix. So all the minors are writing here separately. So minor 1, that is M11, which is equal to 0.54, M12 which is equal to minus 0.51, then M13 which is equal to 0.23, M21 which is equal to minus 0.39, M22 which is equal to 0.62, M23 which is equal to minus 0.25, M31 which is equal to 0.32, M32 which is equal to minus 0.47, and the last minor which is equal to 0.36. See, after finding the minor, we can go for calculating the cofactors. See, minors are given here, and we can easily find the cofactors, that is minus 1 raised to the power 1 plus 1 into the first minor. So it is 1 into 0.54 which is equal to 0.54. Similarly, we can find the cofactors from here. See, each cofactors are calculated here. So we will have the 9 cofactors because we have 9 elements are there or 9 minors are there. So we will have a 9 cofactors as well. And I am going to write the cofactors C11, C12, C13, C21, C22, C23, C31, C32 and C33 separately here, so that we can go for frame the cofactor matrix. So we are going to replace the original matrix by the cofactor element so that we will get the cofactor matrix. So cofactor matrix here it is equal to 0.54, 0.51, 0.23, 0.39, 0.62, 0.25, 0.32, 0.47 and 0.36. After finding the cofactor matrix, we are going to find the adjoint matrix by rearranging this particular cofactor matrix in the way of taking the transpose. See how we are going to take the transpose? By interchanging columns into rows. First row we are going to change into the first column here. The second row will become the second column and the third row will become the third column. So this will be your adjoint matrix. After finding the adjoint matrix, the next step is to find the inverse of matrix. It is equal to 1 by the determinant value. Determinant value is equal to 0.151 into the adjoint matrix which is already calculated here. So if you go for multiplying this again with the final demand vector, so D is also here so that the total output of the each industry can be calculated here. So here the output is equal to inverse into the final demand vector D. So here the determinant value, that is inverse, is already written here 1 by 0.151 into the adjoint matrix into the final demand vector, that is D is equal to 20, 10, 30. So we are going to multiply here, see the first row with the final demand vector. So it is 0.54 into 20 plus 0.39 into 10 plus 0.32 into 30. So we are writing here in the first row. In the second row, we are going to multiply with the same final demand vector. So we will have the 0.51 into 20, 0.62 into 10 plus 0.47 into 30. And the final row again we are going to consider with the final demand vector so that we will get the third row as well. So if you go for multiplying and adding, we will get, see, it is 1 by 0.151 into 10.8 plus 3.9 plus 9.6, 10.2 plus 6.2 plus 14.1, 4.6 plus 2.5 plus 10.8. If you go for simplifying it, 1 by the determinant value into this particular vector, and finally it will give you 160.92, 201.98, 118.54. What actually this vector showing? See, this is the output vector, that is x1. x1 is equal to here 160.92, x2 is equal to 201.98 and x3 is equal to 118.54. So this is the industry 1 output, industries 2 output and industry 3rd output. So in this way we can find the output of the each industry. So let me conclude here. We discussed the 3 industry model of input output analysis. We will see in the next lecture. Thank you.